pi, whoa, negative 1 over 2 is. All right, Luke.
11 pi over 6.
11 pi over 6. What else could I have called that?
Negative pi over 6.
Or negative pi over 6. I asked for in radians.
Okay.
So you would be wrong. Wrong. No, if you know it. I wouldn't take points off if you put both, as long as you had both, right? So when in doubt, put both. All right, cosine inverse of negative 1/2. Who wants to give me that? Jack. 2 pi over 3. Do we agree with that?
I agree.
You sound like you disagreed at first. You're like, I agree.
No, he was like, did I get it wrong?
No, you got it right.
Oh,
Okay.
yeah.
I'm in the same boat as him, so if he's going down, I'm going down with him. All right, what's the arctangent of negative 1? Arctangent of negative 1, 8. Pi over 4? Do we agree with that? Okay. Whew.
Can we do that one?
Yes, absolutely. Okay, arctangent of negative 1. All I need to do is figure out where tangent value is negative 1. So you just go to your unit circle, and you find out where it's negative 1. Well, it's negative 1 here, and it's negative 1 at 7 pi over 4. So we can't do both.
Yeah, it's the first one.
This one?
Isn't...
I'm going to write something really quick.
Oh, wait, why?
Hang on. I'll write something real quick.
Oh, I was looking at the cotangent.
Yep. Cotangent, so it should have been the 7 pi over 4. Or negative pi over 4. Or negative pi over 4 would work too. So I'll put or negative pi over 4. I'm going to go ahead and run through the next one, because your first inclination might have been to simplify this fraction. But just do everything first and then see if you need to simplify it. Because since this is arc cotangent, and cotangent values are not on my unit circle, I have to go through tangent land. I have to go through tangent land because that's all that's on there. So I need to rewrite this as tan inverse or arctan. And if I'm doing the inverse, I do the reciprocal inside. Inverse, inside, reciprocal. Inverse, inside, reciprocal. So it'd be square root of 3 over 1. Which means I'm looking for where tangent is square root of 3. Who ended up getting this one? Yeah. I don't know, is it? Is it pi over 3? Do we think so?
Yes.
Let's look. I'm looking for square root of 3. I'm looking for square root of 3. It's pi over 3. Where you might have gotten pi over 6 is, did you simplify this fraction and just leave it as square root of 3 over 3? Yeah. We didn't actually need to simplify this one, because I had to go through tangent. So let's do the reciprocal first, because if I would have simplified this and done the reciprocal, I would have had to simplify it again, so that would have been double simplifications just to get me back to square root of 3. So if you're given cotangent, cosecant, secant inverses, flip it first, and then figure out if you need to simplify it. Our next one is secant inverse of square root of 2. Who thinks they got this one? David?
Pi over 4.
Pi over 4? Do we all 100% emphatically agree with this answer?
I do.
Oh.
Emphatically, but yes.
Yes, I'm going to do it. I just want to see how we feel about this answer. I'm going to tell you right now it's wrong. No, it's right. These people just erase. I don't understand this. Okay, secant inverse. There's no secant on my graph, so I have to use cosine. And since this is an inverse, I have to use cosine inverse. I'm using the inverse, so I'm going to take the reciprocal of the inside number. Inverse inside. So that's going to be 1 over square root of 2. Well, that form isn't on the unit circle. The unit circle has them all simplified. So I'd multiply the bottom and top by square root of 2, which would give me cosine inverse of square root of 2 over 2. And that means I just need to figure out where cosine is square root of 2 over 2. It is square root of 2 over 2 at pi over 4. That's the answer I had. So you were correct. Jack.
The next one.
Oh, you're already on the next one? I didn't even get to the next one. Okay, what's the answer to the next one? 2. 2?
I got
You got 2? Did anyone else get 2?
I got 2 too.
I got 2. I got 2, 2, 2, 2, 2, 2, 2, 2, 2. Did anyone not get 2? So we knew how to do that one then, I'm assuming? Okay. Let's quickly run through it. So cosecant of 13 pi over 6, I would make sure that 13 pi over 6 does not work. It's not on the unit circle. So I would reduce it. 13 pi over 6, I would subtract 2 pi from it, which would be 13 pi over 6 minus 12 pi over 6. So I'm just looking at pi over 6. Let me erase this 2. Let's pretend I don't even know the answer. So I'm really looking for the cosecant of pi over 6. Cosecant is not on my unit circle, so I do have to go through sine of pi over 6, but I'm going to look for the reciprocal of that answer. All right, so inverse, we take the reciprocal inside. For regular, the reciprocal happens to our complete answer. The way I think about it is, because let's go through this really quick. So I'm going to find sine of pi over 6. So I go to my unit circle, I find pi over 6. Sine is 1/2. The reciprocal would be 2. We always take the reciprocal of the number, not the angle. All right, that works for both of them. All right, inside the parenthesis, that's our number, it's not our angle. So that's why we need to take the reciprocal inside the parenthesis. When I'm just doing cosecant, I'm not going to take the reciprocal of the angle because that doesn't make sense, because then I'm looking for the angle 6 over 13 pi that is just going to destroy your life. So we're not going to take the reciprocal inside, we're going to take the reciprocal of the number once again. Maybe I should draw out this whole thing, that it really is 1 over 1/2, which gives us 2. So we're always taking the reciprocal of the number. All right? And that only works with cotangent, secant, and cosecant. Don't just start taking reciprocals because you heard the word reciprocal and you're just going to take it every single time you see something. All right? People do it. People will do it. On the test, I'll be like, the sine of pi over 3, and they'll be like, 2, because I took the reciprocal. And I'm like, that's cosecant is the reciprocal. All right? So don't fall in that trap of just taking reciprocals because it's fun. All right? It only works for cotangent, cosecant, and secant. It's the only time you have to worry about inverses, reciprocals. And if they're inverses, it's inside. If it's regular, it's just your end answer is the reciprocal. All right, always the number, never the angle. Cool? 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 All right, everyone take out your homework because I'm going to check it really quick. No, I'm just kidding. We didn't have homework last night. We'll have plenty of time to work on it today and Monday, so it won't be due till Tuesday, but hopefully none of it will be homework. So Monday's going to be work day. Tuesday will be a review day. All right, and Wednesday we have our examination. That's, I think, Spanish for test. Could be. I'm good? All right. Applications. These aren't that hard. I don't want to hear no, there's words. This isn't an English class. All we're trying to do is make a right triangle. Our whole goal with any of these is to make a right triangle. So let's read this really quick. So it says a wire 108 meters long runs from the top of an antenna to the ground. So we picture like a telephone.
News.
Thank you, Nick. It is the hypotenuse. Yes, it is. Because if you picture like a tall antenna and a wire going down to the ground, that would be your hypotenuse. Your antenna is going to be your straight up and down side. So let's go ahead and draw that awesome picture. I am terrible at drawing, so we're just going to say that's my antenna and that's my wire. All right? That's my antenna. Let's just call it ant. And that is my.
If there's like a gust of wind that's gonna smack her.
No, it's really strong.
Oh.
It's really strong. It's a really strong wire. Don't worry about it. It's a mathematical wire. It can't break. I'm positive. All right, so that wire is 108 meters long, and this is going to form a right triangle. Now it says the angle of elevation of the wire from the ground is 42.3 degrees. So they gave you two hints there. They said angle of elevation, and then they said from the ground. So you should have been able to recognize that 42.3 degrees, I should put my arrow going the other way, is right here. So that's 42. I can write it right inside. I got enough room. Why would I be lazy? 42.3 degrees will be right there. So they actually told you they gave you which angle it was twice. Angle of elevation would have been enough to know what value it is. If we look down below, angle of elevation is always where you're looking up. All right, so this wire is kind of looking up. Angle of depression is always looking down. So if I said angle of depression, it would be the top one because it's going down. So angle of elevation is always the one going up. Depression is the one always going down. So if I said the angle of depression was 42.3 degrees, you would have to label this one up here. But they give us 2 points. They said from the ground and angle of elevation. So it's going to be 42.3 degrees right there. And it says find the length of our antenna. So my antenna is X. Which trig function should I use? I heard a very soft answer. I heard another soft answer. Oh, and a nice firm.
Sine.
It's sine, yeah. We're going to use, for sure, use sine because the side opposite is x. So it's opposite over hypotenuse. That sounds like sine. I'm going to go ahead and write the whole sine thing down. That sine of theta is going to equal opposite over hypotenuse. I fill in the information I know. Well, that would be the sine of my angle is 42.3 degrees. My opposite's x. I don't know what that is, but I do know my hypotenuse is 108. That means to get x by itself, I don't need to take the inverse. I do not want to see this on the test. I don't want to see people taking the inverse because it's fun to take the inverse. All right, you want to get x by itself, so you're just going to simply multiply both sides by 108.
Do we have our calculator in degree?
I would have my calculator in degrees since it says degrees. So we're going to have x equals 108 times sine of 42.3 degrees. And we come up with some number that I don't remember. 72.7? 72.7 meters about. Now, does it say what you need to round to? No. So my default mode is always to the 10th. If I don't tell you to round, I can't really take off points if you round to the first, but I'm just saying your default mode should be to the 10th. It is about as accurate as you want on a problem like this. Yeah.
I got 121.
Cool. What mode is your calculator in?
Degree.
And we typed in 108 times sine of 42.3.
I actually did 180.
Ah, JK. Solved your problem. If you ever get an answer wrong, just say JK. I was just kidding. I didn't think that was my answer anyway. I just wanted to see if you thought it was the answer.
That's correct.
Nick, did that work then?
Yeah.
Okay, good. All right, so once again, I just give a little brief explanation of angle elevation, depression. The next problem has a very complicated kind of twist to it. It's kind of a jerky thing, and it wouldn't happen on a test or homework, but I just want to go over it really quick. So it says if a skateboard ramp is being built and the longest side of the ramp is 12.7. Your natural instinct would say that's the hypotenuse, right? This question is actually talking about just one of the two sides. It's talking it like the hypotenuse would be called the hypotenuse. All right, so these are possible out there. Just something you might see, not in this class, not really on a standardized test, but just so you know. So that is not our hypotenuse. That is one of our sides. So first I'm going to build this awesome ramp. I got this awesome ramp here. I got this guy totally driving a skateboard. Look at that. Well, it's electronic. Can't you see the handlebar? And it's, yeah, it's a hoverboard. But it's a real hoverboard. Hang on, it's a real hoverboard.
It's like actually hovering.
Yeah. And his name is Jeff. And he's hoverboarding up that. That's why he's driving it, because it's a hoverboard. He's driving it.
He's just like doing the splits in midair too.
He could be hovering. But anyway, that's Jeff. That's Jeff and his ramp.
Or he's like wearing a giant dress.
And we know one of the sides is 12.7, but just by reading 12.7, we don't know which side it is.
But it says the height is right.
We do have to continue reading and say the height is 4 feet, so this is going to be 4 feet.
And that's
So that would make this one the 12.7 feet. And they said they want to know what is the angle of elevation for the ramp to the nearest tenth of a degree. Angle of elevation is always the one going up. All right, so this one's the one going up. This would be angle of depression because it goes down. So that is the thing we're looking for. We're looking for that angle. Now we're not using the hypotenuse. So that means I can't use sine or cosine because those both have the hypotenuse in it. So I must be using, I must be using tangent. So I'm going to say tangent of theta is going to equal opposite over adjacent. I still don't know theta though, so I can't plug that number in. So I still have tangent of theta equals my opposite was 4 feet over my adjacent, which is 12.7. So I'm going to get tangent by itself, so I'm just going to divide both sides by tangent, okay?
No.
But watch. See, it crosses right out. No, you can't do that. You can't do that. Guys, shh. You can't do that. You can't divide by tangent. It's not a multiplication. You always have to do the inverse. The inverse of a tangent function is not division. It just doesn't make sense. The only thing that's an inverse of a tangent function is a tan inverse. So I'm going to take the tan inverse of both sides. I'm just going to do it up here. And maybe I'll do it right here. Tan inverse. Our tan inverse and tangent actually turn to 1. And so we're just left with theta is going to equal our tan inverse of 4 divided by 12.7, which is going to be about, rounded to the nearest tenth of a degree. I got 17.5 degrees. Good? All right, you have 2 homeworks.